x over 2. And I'm going to use method number 1 for this. You can choose either method, but I'm going to kind of treat the top as its own pair and the bottom as its own pair. And it really is up to you and what you see, what makes it easiest for you to work through. The other thing that I like to do is when there's a whole number, I like to make that whole number into a fraction just so visually I see 2 fractions sitting there. So if I'm just looking at the numerator, 2 over 1 minus x over 3. Ava, what would be the least common denominator of the 2 fractions on the top? 3. So what would you do with the 2 over 1 if you wanted to have the least common denominator of 3? Yeah, multiply it by 3. So we wanted to have the least common denominator, it becomes a 6. So I would have 6/3, which is the same thing as 2, minus x over 3. And then Ava, how about the denominator down there? So that 1 would become a 2. Yeah, 2 over 2 is the same thing as 1. So now I have my fraction pair in the numerator. It has a common denominator. The fraction pair in the denominator has a common denominator. And I can add them together. So I would have 6 minus x over 3. And then 2 plus x over 2. So your numerator's fraction, the denominator's fraction. And then the last step here, that is my main fraction bar, but a fraction also means division. So you're taking the expression in the numerator and dividing it by the expression in the denominator. Well, from section 8.4, we said division is really multiplying by the reciprocal of whatever follows the division sign, or in this case, the division bar. So we would take the reciprocal of the denominator. So the numerator remains. We are changing it to multiplication, and we're taking the reciprocal of the denominator. And then we are multiplying here, but we are not distributing the constant terms through. So 2 times the quantity 6 minus x, 3 times the quantity 2 plus x. Questions on number 4. So again, that was method number 1, Eva.
How do you know when to distribute it through and when not?
Never. Never. Keep it factored.
So even if you have 3.
Even if you have.
So if you have number 10, if you have all 3, or not. What if it has 3? Would you keep those all factored?
Mm-hmm.
Okay.
Yeah. I mean, one, it's less work for you, as you don't have to do the multiplication, but it is truly simplified when it's in factored form. Yep. Other questions? So I wanted to look at 6 because I thought that one looked a little different as well. Just has a 2 on the top. 2 is by itself. I don't have to add it with anything. So you're not going to do anything with the numerator there. Keep the 2 by itself. So we're going to kind of ignore that 2. So keep 2, keep my fraction bar. The denominator says 1 over x minus 1 over y. Grace, what would the least common denominator be between 1 over x and 1 over y? Yeah. So they need to become the x and the y. So Grace, we have 1 over x. What does that one need? Yeah. And then, yeah, this one needs an x. So it becomes x over xy. Again, the goal of getting a common denominator is so you can combine them together. So once you place those variables on the top, make sure you perform the subtraction sign, because that's the goal of having a common denominator, so you can actually combine them and subtract. So we still have the 2, But combining the fraction, we have y minus x, and then the denominator was x times y. So 2 division bar or divide, and then I'm taking 2 divided by the quantity y minus x over x times y. So if I use the same process as we did before, the numerator times the reciprocal of the denominator. So xy divided by y minus x. Division is really multiplying by the reciprocal of whatever follows the division sign. In this case, it's whatever's underneath. And then again, if you want to look at that 2 as being a 2 over 1, just so you see a fraction times a fraction, this would then make 2xy, y minus x. The denominator is subtraction. It's not a product. Nothing can cancel with the numerator. The numerator is a product, but the denominator is not.
I'm sorry.
That's
So
okay.
why would that be- So why wouldn't that be 2 parentheses x1?
It's all multiplication. So we usually wouldn't put parentheses around something that isn't like addition or subtraction because it's a quantity. But each term is being multiplied. So if this said 2 times x, hold on. If this was x plus y, then that 2 is being multiplied by the quantity x plus y.
Oh, okay. Thank you. Sorry.
So there is a difference. So 2 times x times y, they're all being multiplied together. Question,
So,
Ella, sorry.
I also put the least common denominator under the 2 at the beginning, and then add xy to the 2.
Yeah, that'll work. And then they cancel. Yeah, so that would be using method number 2. Yep. So that works as well. I just use method number 1. I figured we'll leave the 2 alone. Jaden.
So it's like, why are you multiplying the 2xy together opposed to like the 2, like 2 then the x plus y? Is that like the same type of thing as like why yesterday I think we had one that like multiplied 2x times x and it was like 2x squared? Is that like
Yes.
Okay.
Yes. Yes. Julia.
Will both the methods like work every single time?
Yes, you could use either method. Either of them will work. Yes. So if like Ella used the second method, so she had a common denominator with the 2. So Ella, you had 2xy over xy, correct? Yeah. And then that would still be y minus x over xy. So the xy, the denominator cancels. You get the same exact thing. It just depends on what you see and the process you want to take to get there. But this, I think, is what Ella did right here. Either one is correct. Same answer. Just depends how you want to get to that step. So do you want to multiply everything top and bottom by the least common denominator? Or do you just want to worry about one part of the fraction and then multiply by the reciprocal? Ella. Yeah. Can you tell me how you factored the denominators? All right, so number 11 is a subtraction problem. Factor first, because you're finding the least common denominator. And anytime you go to find the least common denominator, we have to factor first. And then we want to think, what would the least common denominator be? And there are 2 fractions here that are being subtracted. So take everything from the first fraction, x minus 2, x minus 1. Look to see what's different in the second fraction. Well, the x minus 2 is there, but there isn't a 3. So that would be my different part. So I need to place a 3. So x minus 2, x minus 1. The next part. Now look at your numerator. We have a negative x plus 1. What do you need to multiply that by so that you have the least common denominator of that first fraction. So there's an x minus 2 and an x minus 1, but it's missing anybody? A 3. So we need to multiply this by 3. If you look, when you compare your numerator and denominator, if you're using or writing the missing piece in the numerator, these 3 pieces together should make the least common denominator. The denominator, what it has, the numerator, what it's missing, but combined together is the least common denominator. 3 times x minus 2, x minus 1. So looking at the next one, we have 3 times x minus 2, but it doesn't have x minus 1. Oops. X plus 3 is a quantity. X minus 1 is a quantity. Quantity is anytime you have 2 or more terms combined with addition or subtraction. So again, looking, here's my least common denominator. The part that's in the denominator, the missing piece in the numerator, together combined, they make the least common denominator. So Gabby, so if we multiply the numerator, what do we get for the left side? And then we have negative 3x plus 3. So look across the numerator. You're subtracting, which means you're adding the opposite. That minus 3 becomes a plus 3. Everything becomes the opposite. Subtracting is adding the opposite of everything behind that fraction. So then, Jaden, if you combine your like terms, what do you find?
X squared plus 5x minus, oh wait, this is after I took out the negative, I'm sorry.
That's right, I threw it in.
X squared plus 5 minus 6, when I distributed out the negative sign out.
You're good. So she took a negative out to get x squared plus 5x and then minus 6. So we applied the least common denominator to the numerator, whatever part it was missing. And then you add your like terms or combine your like terms. Notice that the x squared is negative. So Jaden factored out a negative x squared. And this is what we have left so far. So we have a negative x squared plus 5x minus 6 and a 3 over x minus 2 and x minus 1. The parentheses looks like it's factorable. Jordan, could we factor x squared plus 5x minus 6? Yeah. Perfect. What do you notice when you factor that? Exactly. So the numerator is factorable. Once you factor, the x minus 1 cancels. And then again, leave the negative outside. Keep the x plus 6 inside. You already pulled out the negative. Don't distribute it back through. Leave the 3 outside. Keep the x minus 2 inside. I cannot enforce enough. The more work that you write down, the less mistakes you will make. So if you show the top and show what you're multiplying each numerator by, instead of mentally trying to do it, you will make less mistakes. This is a problem you won't see on your quiz today because I made the quiz super easy. But you would definitely see something like this on next week's test. Jaden.
Okay, so this isn't about this problem, but number 10, I marked down an answer, and this is also what was in the key, but it was 6x squared plus 28x minus 28 is what the numerator was. And I was wondering why you did not flag.
Yeah, I probably was just being lazy and in a hurry and I didn't factor out it. Yeah.
Okay.
It was more of, yeah, it should be factored out.
Okay,
Yeah.
so yeah,
Nope.
I finished with that. too,
Good,
and I was
yeah,
like,
good thing to ask. Yeah. The 2x should be factored out there. Julia.
"Can you go over to-"
I will answer your question. I'll come back and answer it once we practice time. I want everybody to have some time to practice. So I'm gonna give you a little quiz. Once you're done with the quiz, you're gonna go into Google Classroom, open up the assignment for today. It is a review worksheet summary. And I'm gonna give you the little quiz. If you're at home, the quiz is posted for you.